and welcome to a bonus video. In this, I'm going to cover some cleanup that I did to the shader code, and I added an extra feature which I'm going to re-add. So some initial cleanup that I did is I moved the mask, power, and strength parameters into the generate slope blend mask so that the output of generate slope blend mask is the final, not edited on at all. And also I removed the half 3 slope, the half 3 V normal world space conversion. So before I was doing two conversions. I had this conversion here, and then I was also converting the V normal tangent space into world space. So instead of doing that calculation, I completely removed it, and instead I'm just using the attributes.normalWorld. And this saves me from doing a bunch of calculations, so this actually is a pretty big improvement. The next thing I did is I went up into the generate slope blend mask, and I basically moved the code for the mask strength into the generate slope blend mask, as I said before, and I'm passing in the slope height into the function here. So the next thing I did here is, which is what I'm going to redo right now, and that is adding Vertex color to the shader effect. So in this case, Vertex alpha, as you can see, in .color.w is the alpha channel of the Vertex color set. So in Max, in my case, you can take a vertex paint and you can paint out an area that you don't want. Basically, the black is no slope blend. So say I went over here and I said, okay, let's just, Vertex alpha. So this is clear, right? So this is going to be slope blending on everything. Say I wanted to basically have the inverse of what I had before, where I had, let's just increase this a little bit. Say I just wanted the slope blending to happen on the rock, main rock, and not on anywhere else. I can just apply, here we go. Oh, that didn't work as expected. Okay, fine. Be that way. I'll just have to do it this way. Okay. So we're going to basically say that the only slope blending that we want to happen is going to be on the main part of the rock. So let's just go ahead and re-export this. Okay, and in here you can see now the slope blending is only happening on the main point of the rock, and we can disable that by disabling vertex colors, and then our slope blend will now be on the whole asset again. This is basically a free operation. It's a single multiplication per pixel, which is pretty cheap, and adding the functionality was pretty easy. It's just this one line of code here, the vnormal top facing multiply equal in .color.w. Once again, it's the alpha channel of the vertex color set. You can do this in any application: Maya, Max, Modo, 3D Code, ZBrush, just vertex colors. You can add additional functionality. You could, for instance, use a different channel if you want by simply using the RGB A or XYZW, as I have here. Either one of the naming conventions will work just fine, but I think you should stay consistent. The XYZW convention is the one that's used in CryFX, so I suggest you use that. And once we've done that, this shader is now pretty much done. I mean, we can add one more thing, and that is if you want to take the normal function and add the ability to use a world space normal to break up, or add rather, to the detail of your slope blend. So for instance, we can pass in the V normal tangent space into our generate slope blend function. So we're going to pass in a half 3 normal. We're going to call this in normal. Okay. So after all this, we're going to take the same V normal top facing, And we're going to multiply equal the v. Yeah, we can do it this way. V normal tangent space. Oops. This won't be quite right, but just as a general expression, this will work just fine for the purposes of our test. So I'm passing in the in normal here. And actually, I need to name this in normal. A little bit of a lapse there. So let's save this. I believe I added in all my semicolons. Yep, added in my semicolon, but I'll need to clamp it. And I don't have a parameter. So the best thing you can do when testing out this sort of thing is, if you want to see what you're looking at, well, since it's a tangent space normal, it's going to work a little different. But if you wanted to preview something like this, let's say we wanted to do it this way instead. I'm just going to give this as an example to show you there's multiple different ways to handle the same type of thing. So say we don't pass it into here. Say instead we want to use the normal world before we apply anything to it, and we can run a similar thing to how we get the vertex normals. So we can say slope mask is equal to actually let's do times equal to attributes dot world normal world, and then we're going to have to get the dot product between the normal world and a half 3 0 0 1. This should get us once again the top facing normal of this. So I believe this should work if my mind is working correctly. Yes, okay. So this is using a world normal, and I think actually we can hook up the tester to it. If we multiply this by the tester, so let's put this in a set here, and let's multiply by the tester. By the way, the tester is, once again, it's the setting in here, this right here, SB tester. So this should show us in effect what we're doing when we're affecting this. So tester. As you can see, we really need to clamp that. Make sure our values aren't getting out of whack. So now we're going to have to clamp that, and making this a little complicated. Did I add? Okay, yeah. Clamp. And then in here we can add between 0 and 1. Ta-da! All right. I may change that clamp a little bit. But, so this is an example of something you can do. You can also preview the normal. So if we want to comment this out, we can go down here and we can say after our C albedo here, C albedo is equal to, this would be basically this function here. This will allow us to preview what we're looking at, because I'm not seeing the results I would have expected. Okay, so yeah, you see how much more information there is in here. This is taking this normal here, but as you can see, we're getting all of it. So because this is a world normal, and this is something that I had actually kind of forgotten about. If we want to make this work, we're going to need to do something just a little bit different. So use world normal. We're going to take our value here, and we're going to plus, oops, we're going to add to the pixel instead. Okay, just comment this out. Reload. Okay, yeah, this is much more along the lines of what I would expect. And then you would need to add a cheap contrast node to this. We could try and feed in the tangent space normal instead. I actually haven't tried that before. So let's try that. Let's feed in here the tangent space normal. V normal tangent space. Yeah, that's what I thought. Okay. Although I should probably check my tester values. Yeah, it's just basically not going to work at all. Yeah. You can actually invert that effect. But yeah, I mean, that's significantly more detail on the actual blend. In fact, it might be a little too much. Really, you just want to mess with these values in your actual shader. So as you were saying before, the world space normal is giving me a lot of detail in it. You would need to actually take your mask. I'm doing this in post, but really what should be done is that your mask should be kind of over top of this so that you don't get all that extra crap. Instead, you're kind of just adding to it. But I'm just showing that you can do things like this. You can derive maps from all kinds of stuff. So, and you should think about reusing as much as you possibly can. In the case of this, I'm just going to change this to temp mask. It's equal to. And then we're going to do this. Really? Oh, shoot. Did I get rid of the wrong thing? Oh, no, okay. I forgot to. That's the problem with doing this this late at night. Okay. That is, like, really cool, though. Like, if we just need to control this. Because, like, if you could, if you want to, like, this is some seriously good-looking snow. Like, just it even kind of piles up. It's pretty cool. Really, I mean, really, we just need to get, we just need to derive a better world space normal conversion. So, there's a few different ways we could do this. I might cover that in a different video. But, okay, this has just been running through, just messing with it. I mean, we added vertex colors. I ran through cleaning up the shader. This has just been experimentation. In the next video, I will probably run through the exact right way to do the world space normal calculation, and maybe we can add a parameter for it specifically. Yeah, so there's more videos to look forward to. This one's been a bit rambly and just messing around, so sorry if it was a bit boring, but it's just good to see just messing around with it rapidly and just messing with stuff. And we've already, I mean, as explained at the beginning, we've made this shader significantly more efficient, so we have some more room to play. And we've moved all of our work into the generate slope blend mask. So that's really cool. We'll get into world space normal stuff in the next video.